Hey guys, this is Srini here, and in this video let's talk about something that's very basic to image processing. And many of you, especially the ones who just got started and you started watching my videos and you learned about what Gaussian smoothing is and what edge detection is and many of the other image processing operations, but then my examples in the videos used only single image, but you want to apply this to multiple images. Probably they are all in a folder, or maybe you're working with a image stack or a time series. How do you apply a function or an image processing operation to multiple images? Okay, so let's jump in and let me just show you what we are dealing with here. First of all, let me open the folders. Okay, so I dumped a few images. Again, this can be thousands of images, but for now I'm going to work with 3 images in this folder. And notice that all 3 of these are different size. Okay, I just want to squeeze in like resizing as part of this tutorial so you can kind of quickly learn about it. Again, back to the basics. I've been talking about deep learning quite a bit, but then I don't want to ignore those of you who just started, with coding. So this is for you guys and for everyone. There is always something to learn from every video. Okay, so these are, so let's say we have a whole bunch of images in a folder called images. And let's smooth it using Gaussian smoothing and dump all the output images into the smooth folder. One other thing I would like to show you is not just processing images in a folder, but processing a time series or a 3D stack. Okay, oftentimes when you deal with Tiff images, you can work with multi-dimensional Tiff images. So in this case, the example I'm going to use is this image, which is a time series. As you can see, as we go along, things change. So this is a time series of 10 different images. Okay, and let's load that image and see how we can apply a function to each slice in that image. Okay, so that's the plan for today. Now, there are many ways. I hope you watched my video on the topic of glob. If not, I recommend you watch this video, and that explains what glob is. So for now, let's go ahead and use that. Okay, so first thing first, let's make sure we are in the right directory. So present working directory. Yes, I'm in applying image processing. Otherwise, you change the directory by using cd, or again, while I'm giving you some tricks, in Spider by default, when you go to preferences, okay, it says where do you want to run this? I think it's one of these. I forgot where you'll see that. I think the current working directory right there. So if you select the current project directory or use home directory and the current working directory, what that means is when I run the file, it automatically updates the present working directory. So the trick I usually use is I do intentionally do some semantic mistakes, like right here, some mistake. And when I run the program, you see it says invalid syntax. Did I say semantic? I meant syntax errors. And now if I go back here and then do my present working directory, it should change it. Okay, let's get back to what we are supposed to do here, which is using glob. Again, I'll show you 4 different ways. Well, 2 primary ways and then a way to work with multidimensional images. Okay, so using glob, what does glob do? It lets you walk through the folders and identify all the file names or extract all the file names. So we can just use that to read images. So in this example, let's go ahead and import these libraries, which is OpenCV, glob, to go through the directories and identify our files. And I'm going to use Gaussian filter from skimage.filters. It doesn't matter. This is just any operation you would like to do. So you can use OpenCV or any other library. And I'm going to use image as ubyte, because when I'm saving images back, when you apply some of these filters, the images get converted to floating point numbers. And when you save the image as is, you will not be able to see anything. Okay, so you have to convert them to ubyte before you save them as JPEG or PNG or whatever image format. Okay, so first thing first, I'm going to define my path as my test images/images. Let me make sure. Yeah, so I'm in this is where my code is. Test images/images, these are where my files are located, right? So that's there. And I'm giving starting a variable called image number, because as I go one image after the other, I want to tag a number to it when I'm saving, so the same image doesn't get overwritten. Of course, you can always use the same file name. Yeah. Again, let me go through this step by step. So for file in glob.glob path, what that does is, well, that's exactly why I have the print statement. So let's go ahead and do that, path is not defined because I haven't executed these lines of code. So let's go ahead and do that. Okay, and now let's run these 2 lines of code. Now you see how it's saying print file. So every time it goes through the for loop, it's updating what that file is. Initially, the file is bsc.tiff, next cast iron.tiff, next cast iron.jpg. So I'm mixing tiff and jpeg right here. Again, the reason I'm using all of these is 3 different size images, 3 different extensions, but you can see once they're converted to NumPy array, it's all the same. Okay. So these are the images, image names that glob extracted for us. Now, how do you read a file? CV2, I'm using OpenCV. You can use scikit-image. It's up to you. All I'm doing is reading the image. So let's do cv2.imread file. I'm reading them as, grayscale in this case, but you can read them as color depending on the type of, operation you plan on doing to these images. So let's do this one more time. Now let's run that. Now it's actually reading one image after the other. So apparently the last image is a very large image of size 2K by 2K. Maybe we should resize, but I'll save that for later. Okay. So now you can see it's reading one image after the other. So as long as I'm within this for loop, I can do all kinds of operations. So let's go ahead and do my smoothing. You can use a scikit-image, you can use OpenCV because Gaussian is present everywhere. Yeah. So my smoothed image is basically my Gaussian function that I'm or method that I'm importing from here, applied onto my image, right? Onto my image. And what is my image? Well, for the first iteration, my image is bsc.tiff. For the second iteration, it's cast iron1.tiff, and then it's cast iron2.jpg. Okay, so every time it goes through this, that's why it's important to put this in the for loop. Again, I'm talking a lot of basics, but again, this is for those of you who are still getting started with this type of stuff. Okay, and with a sigma value of 5, again, I've done a very long video on Gaussian, so go ahead and watch that. So all I'm doing here is applying the Gaussian, and instead of saving this as is, I'm converting them this as ubyte. If I don't do that, then the image would be a floating point values, and when you save it as JPEG, you would just see a dark image. Okay, so this is my smoothed image, and I'm still in the for loop. Let's go ahead and write that, meaning let's go ahead and save it in a different folder. So where am I saving it? Test images smoothed, and obviously test images underscore smoothed right there. Right now I have nothing. And what file name am I given? If you don't change the file name every time you go through, then the same file gets overwritten, right? So you have to change it. So in this case, I'm giving it a name called smoothed image. To that, I'm adding image number. Remember, image number for the first image is 1. And then I'm increasing the image number by 1 every time it goes through the for loop. So image number 2 would be smoothed 2. So this would be smoothed image 1.jpg, smoothed image 2.jpg, 3.jpg, and so on. If you want to keep the original file names, all you need to do is just put file right here. Instead of smoothed image, just put file right there. And then the first time the file would be bsc.tiff, right? So it would be the same name. And you can strip the file name and do all kinds of stuff. Again, watch my video on glob and OS. So let's run this and see how this works out. So this is pretty simple. As you can see, few lines of code. There you go. It's done. Now I have my smoothed images right here. Okay, so I have my original images right there and my smoothed images right here. Okay, so this is one way of doing things. What's the second way? Second way is by using OS. Okay, again, I did videos on OS and glob, so go back and watch it. So let's clear everything and start from scratch. Okay, let's clear everything. And now what shall we do? Let's run these libraries exactly the same, except instead of glob, I have OS. And OS is right now you can walk through the root directories, files. Okay, again, you can go ahead and print within each of this to see exactly what's going on. Now for each of these, for name in files, okay, so let's go ahead and print that. What shall we do for name in files? Let's just run all the way up to here. Okay, so you can actually see what it's doing. You see, I got exactly the same thing that I got using glob. Okay, here, except there is a slightly different way of doing things. Okay, that's pretty much it. Once that's done, again, the rest of the process is the same. Here I defined my image as cv2.imread file. I'm doing exactly the same thing. Image is cv2.imread, but here the path is basically this path. and everything else should be the same. So do I still have my smooth images? No, I deleted them, and let's go ahead and run this. Rest of the code is the same. I'm not changing anything. Let's use the same example. Okay, now let's go back, and it should do exactly the same thing here. So the lesson here is, whether you like to use OS or whether you like to use glob, make sure you put this in a for loop where you're loading an image, doing some operations, saving it, loading another image, doing something, saving it. Okay, so this is exactly what we are doing here. Okay, so in both of these processes, exactly the same. Now, there is one other way that especially we do this when we are doing machine learning type of work, or which is read all the images and create a NumPy array, okay, and then go through each of those array corresponding to each image, process it, and save it. Okay, again, this is up to you how you would like to deal, but I encourage you to learn this way so you know how to work with NumPy arrays. Okay, advanced, when you get into later stages of machine learning, it's all about playing with NumPy arrays. So you have to get a bit familiar, and this is a great exercise to do that. Okay, so what are we doing? Again, let's go ahead and import the libraries there. And what I'm trying to do here is take what we have done up to now. For example, let's take glob and read the files, and instead of processing it, I'm storing it into an array. Let's see how we do that. First of all, I create an empty list called images list, and I define a variable called size with 512, because when I'm storing everything into an array, I want all of them to have the same dimension. You cannot just have one image, one size, another image, another size, and all that kind of stuff. It messes things up. So this works great if you're dealing with, like I said, image stacks for machine learning or other processes. So previously here, I did not resize them, just to show that you can work with different size images, okay, easily. Now, let's go ahead and resize them into the same size so we can capture them into an array of the same size. Okay, so now that we did this, let me define the path as exactly the same as we did before. This part is exactly same as before. For file in glob.glob, print the file name, right? For file in glob, print file and read your image, right? So I'm doing exactly the same here. Print the file and read my image. And after reading the image, I'm resizing it using OpenCV here. But again, there are many ways to resize. I'm using OpenCV to resize my image into 512 by 512. This is how I get all images into the same size, okay? And then I'm going to append this image to this list. This image is nothing but NumPy array. So you'll see what happens once we are done with this. So we did the path thing, and let's go ahead and run this for loop. So I already explained the for loop. So instead of processing the image right within the for loop, okay, I'm capturing all the information. So now if you look at images underscore list, if you come up here, okay, keep an eye right there, images underscore list, it's a list of 3 images, and all these 3 are NumPy arrays. If I open this here, you see my image 0 is 512 by 512, image 1 512 by 512, image 2 is 512 by 512, because we resized it. But the numbers are different because these are 3 different images. So we captured all of this into a list. But lists are very difficult to work with, right? I mean, to go through each of this NumPy array, you need to use like a for loops, and to do math on this, it can be a bit difficult. So we typically convert a list into a NumPy array. If you haven't watched NumPy array video, you have to work with images. So that's exactly what I'm doing in the next line here, okay? My images list equals to numpy.array images list. So when I do this, the list gets converted to an array, you see up here. Now it shows the dimensions. You see the first dimension corresponds to the 3 images we have, and the next 2 are the height and the width, or width and the height, I always forget. But this is the actual dimensions, and this is our number of images. If you have 500 images, that would be 500 by 512 by 512, okay? So now I have an image as a list or as a NumPy array, okay? If I open this, you'll see this is image number 1, image number 2, image number 3, okay? I have 3 images. I'm going through each of this, and you're seeing the pixel values. Okay, why did I do that? Now you can process each slice in the stack. You see, this is slice number 0, slice number 1, slice number 2, each of 512 by 512. Let's do that. How do we process? Again, let's do exactly the same. Image number equals to 1, and for image, okay, in range this. What is this? Images.list shape 0. Let's copy and paste it down here so you can see what that means, okay? So that is 3, right? All I'm trying to do is images list dot shape, which gives me this array. Again, sorry for going through basics, but if you are a starter, this can be hopefully helpful. So if you just look at a numpy array dot shape, it gives you the shape of that array, which is 3 by 512 by 512. Now of this, I just want the 0th value, which is 3. If you have 30 images, that would be 30, right? So that's exactly what I'm doing. All I'm saying is for image in 3 or range 3, which means 0 to 3, go and do all of this. What am I trying to do? My input image, previously our input image is something we read by cv2.imread, right? This is our input image. Now we already have it in an array. We just need to extract that 0th image, the first image, the second image, right? So my input image is my images list, okay? My images list where, okay, let me write down here. Images, let's do this. A equals to images underscore list. This is our list, right? And I just want the 0th one first and all the pixels for the remaining ones. So now from matplotlib import pyplot as plt. Let's just plt.imshow. Let's just have a quick look at our image and our image number 0. I mean, of course, it's showing this in color because cmap equals to gray. Okay, otherwise it uses jet or something. There you go. That's our image number 0, right? Sorry, let's remove all the smoothed ones and let's get back. This is our image number 0. Now, how do you get image number 1? Image number 1, oops, sorry. Let me go back and let's do that. Okay, so image number 1 is just type 1 right there. So now I'm extracting the array for 1. There you go. That's my image number 1. That's exactly what we are doing here in the for loop. Okay, in the for loop for image in range, meaning the first iteration, my image value is 0, next one, next 2. Okay, and then I'm looking at image list 0th one. And then in the next iteration, first one, next iteration, second one. And so this is how you go through each image in a NumPy array, or this is how you iterate through a NumPy array, okay? So now we have our image and rest of it is same. Okay, my smoothed image is image as ubyte, Gaussian, my input image right there with sigma values, and then I'm writing the image and everything else. So the only thing you need to know is, in this example, I'm capturing each image into a series of images, okay? Where we get an array of n dimensions, n being the number of images, by 512 by 512 because we reshaped it to 512. And then we are going through each image. Why did I do this? So I can show you how you can work with time series and multidimensional tips, okay, in a second. So let's run this lines of code for now so we can see how our smoothed images will look like. This is test image, and now let's go to smoothed images. There you go. You have the smoothing done, okay? This is one other way. Now let's do something else which is fun. Remember this image that I just showed you? If not, let's open this image, which is a time series right there. It's a time series TIFF. You cannot have this in JPEG or PNG, but with a TIFF you can have TIFF stacks, okay? This is where you need to be careful. If you actually use, did I include that example? Yeah, let's remove everything and let's go back to basics again. Okay, so I'm again importing the libraries right there, and also the last one. And now I'm defining my file or a path. In this case, this is my file name. And if you use OpenCV to read this file, let's go ahead and use OpenCV to read this file. Now you see how it's basically saying this image is an image of 289 by 400 because OpenCV doesn't understand TIFF stacks. It only looks at the first image and then, okay, there you go. So if you want to work with TIFF stacks, do not work with that. Okay, so let me comment these out. I just included that so you know what I'm talking about. And now let's just look at importing TIFF file right here. Okay, so TIFF file is a library. Again, if you don't have it, just pip install TIFF file. So TIFF file is a library that helps us. I think in scikit image for TIFF files, it uses this library in the backend. So let's use that and imread exactly the same file again. Okay, and now you should see if up here now it says 10 by 289 by 400. So I have 10 of these images. In this case, it's a time series, and each image is 289 by 400 in size. That's what this means. Now you know what to do. Once you have the array, we're going to do exactly what we did up here. As you can see here, for image in range 0 to image shape 0, which would be 10 this time, right? So if you just type image shape 0, which should be 10, because we have 10 images. So for image in 0 to 10, meaning the first iteration, the value is 0. For image, the value is 0. Next iteration 1, and so on. My input image is image, and then image 0, and all the pixels for X and Y, and then rest of it is the same. So this is it. So this is how you do this, and you can also put this, I'm showing you how to save this into a separate folder. You see how we have 10 images that are smoothed. In fact, you can process this entire thing and then put them into a stack and output a Tiff stack if you want. So I think a rather long video on what some may perceive as a trivial topic, but while you are learning, I hope this can be a very, very useful video, and I hope you appreciate this and keep asking these questions. I'm doing this because quite a few of you inquired me about it, and I did reply to a lot of you, but I think this is a much better way, and I'll share the code as usual. Please look at the description. Thank you very much. Please do subscribe, and please do provide your feedback or requests or anything. If I have time, if I have skills, I'll definitely work it out and create a video for you guys. Thanks.